Hi folks, this will be a very quick example of how to do long division with a two-digit divisor. In this case, our divisor is going to be the two-digit number 38, and the division problem we're going to work out is 2,394 divided by 38. Long division with a two-digit divisor works a lot like division with a one-digit divisor, but the main difference is, since the numbers are so big, we have to do quite a bit of estimation and kind of intelligent guesswork. And sometimes we'll make the wrong guess, and so we have to use our eraser potentially quite a bit. Like always, we start working the long division problem by looking at the dividend under the rooftop symbol, and we start from the left looking for our focus. In this case, 2,394 is our dividend. We look at that 2. Can 2 be divided by 38? No. So we add one more digit off to the right, 23. Can 23 be divided by 38? No. So it looks like our focus is going to have to be 239, because 239 can be divided by 38. And here, of course, is our first big challenge. 239 divided by 38? Off the top of my head? How do I figure that out? We don't figure that out. We round. We round 239 up to 240. And we round 38 up to 40. Now we can have a lot better success at making an estimate. 240 divided by 40. 24 divided by 4 gives us 6. So let's try putting a 6 up above our focus and do the multiplication and see where it takes us. Feel free to work out the multiplication separately off on the side if you need to. 6 times 38. First, 6 times 8 equals 48. Carry the 4. 3 times 6, 18, plus 4, 22. 228 does indeed fit into 239. So now I can do the next step of my long division and subtract. Subtract 228 from 239. 9 minus 8 equals 1. 3 minus 2 equals 1. 2 minus 2 equals 0. So I end up with a new potential focus of 11. Can 11 be divided by 38? No. I need to pull down the 4. Can 114 be divided by 38? Yes, you bet it can. And once again, I'm going to estimate. And here I'll let you in on a little tip. When I'm rounding, I usually find that I'm more successful if I round both numbers, both my dividend and divisor, in the same direction. So I'm rounding that 38 up to 40, just like I did last time. And so I'm going to take the 114 and round it up to 120. So now I can say, 120 divided by 40. 12 divided by 4. It's going to look like 3. So I'm going to make my best guess is 3, put that up above my focus, and do the multiplication. 3 times 8 equals 24. Carry the 2. 3 times 3 equals 9, plus 2, 11. Whoa, 114 minus 114 equals 0. There's nothing left to pull down. I am done. And the answer to what is 2,394 divided by 38 is 63.
Welcome to my musings on the meaning of multiplication and division in context by me, Gwen Fisher, pencasted with Doceri software. So multiplication describes repeated groups or repeated sets. So for example, 5 sets of 3 buttons can be drawn like this. By using multiplication, we can find that 5 times 3 is equal to 15. 15 tells us the total number of buttons in the 5 sets. So there are 15 buttons altogether. Let's do a related but different example. 3 sets of 5 buttons. We can draw a picture that looks like this, and here we see that 3 times 5 equals 15. And we can notice that in both of these cases we get the same result. But these drawings don't really make it very obvious why 5 times 3 should be equal to 3 times 5. I mean, it's easy enough to check when the numbers are small like this, but if we were using huge numbers, it might not be so obvious. So let's redraw the pictures. So in the first case, I'm going to draw my sets of 3 objects where the 3s are going into rows. So I have 5 rows of 3 dots or 3 buttons. And in the second case, I'm going to draw them vertically like this. And so here I'm going to get 3 columns of 5 dots. And in this representation, it's a lot more obvious why 5 times 3 should be equal to 3 times 5, because I've arranged the dots into the same configuration, or what's called a rectangular array in both cases. So let's do a unit analysis where we look at the units in these multiplication equations. So in the first case, we have 5 sets times 3 buttons equals 15 set buttons. Now, set buttons, that's a unit that really bothers me. Really, I want 15 buttons on the right, but on the left, then I have set buttons, and on the right, I have buttons, so I have to fix something on the left. So the problem is with the 3. It's really 3 buttons per set, which I can write as buttons over sets. And then in the second case, I have 3 sets times 5 buttons per set is equal to 15 buttons. And so you can see that in terms of the units, what I've done in these 2 problems is I've switched the sets and the buttons per set on the left side of the equation. And other examples of units that we might use for multiplication problems include things like seconds times meters per second equals meters. So this is the classic velocity and distance equation. Hours times dollars per hour equals dollars. This is useful when we're talking about working a job and how much money you make. And then cars times people per car is equal to people. This might be useful if we're taking a bunch of children on a field trip and we want to know how many cars we need in total. Now let's look at division. Division is the undoing of multiplication. So mathematicians, every time we do something, we want to look at how we can undo it. So in the case of multiplication, the undoing of it is division. So let's look at our particular example here of 3 times 5 equals 15. One way that we can undo this is to take 15 and divide it by 3, and that will be equal to 5. And then the other one is 15 divided by 5 equals 3. And if we put units back into these equations, we can get a better understanding of how we can think about these 2 equations on the right, how we can think about them differently, how they might be different from each other. So what does this mean in the context of buttons and sets of buttons? If we take 3 sets and we multiply by 5 buttons per set, we get 15 buttons. And if we strip off the numbers, we get this simple unit equation, this unit analysis equation. I can switch it around to find the 2 division problems. So the first one would give me buttons divided by sets is equal to buttons per set. And if you're familiar with this notation, this might seem pretty obvious. It's almost just a change of notation from the left side of the equation to the right side. And the second one is buttons divided by buttons per set is equal to sets. And this one is perhaps a little less obvious. But if you're familiar with the division of fractions algorithm where you invert and multiply, you should be able to convince yourself that this makes sense. Now in the first case, if I put the numbers back in, I get 15 buttons divided by 3 sets equals 5 buttons per set. And if I want to draw a picture, I can deal the 15 buttons evenly into 3 sets. So I establish my 3 sets first and I just deal them out like they were cards. And the question I'm asking in this case is how many buttons are in each set? And I can just count them and see that there are 5. This kind of division is called dealing division. In the second case, I can look at 15 buttons divided by 5 buttons per set and get 3 sets. And here, if I want to draw a picture, I'm going to measure 5 buttons into each set in the same way I might measure cups of flour into a bowl. So the first set has 5 buttons, the second set has 5 buttons, every set has 5 buttons, and the question I'm asking is how many sets are there? And I can count that there are 3, and this is called measurement division. Now let's look at this in a slightly different way. If we ask the question, what is 6 divided by 3, we have really two different ways to solve this, depending upon whether the 3 is the number of groups or sets, or 3 is the number of items per group. So in the first case, if we take 6 items and divide by 3 groups, we draw out our 3 groups, and we deal those 6 items amongst the 3 groups until they're all dealt out, and then we see that there are 2 items in each group. So 6 divided by 3 is equal to 2 items per group. And the other way to do this is to take 6 items and divide by 3 items per group. And so here I put 3 items in the first group and 3 items in the second group, and I can see that there are 2 groups. So 6 divided by 3 in this case is 2 groups. This is measurement division, and the first one that I did was the dealing division. And in both cases, the corresponding multiplication equation is 2 times 3 equal to 6, or if you prefer, 3 times 2 equals 6, where 6 is the total number of items. I haven't labeled the 2's and 3's in these equations because they're different in the 2 different types of division. Now, mathematics is not a spectator sport, so I want to leave you with some problems for personal improvement. The first one is, if Sally can run 10 miles in 2 hours, how fast does Sally run? After you've answered this question, you can decide what type of division is this. Is it a dealing division problem, or is it a measurement division problem? And in the second question, Maria wants to buy a coat, and the coat costs her $90. If she makes $20 for each hour that she works at her job, how many hours does she have to work in order to purchase the coat? And again, after you've solved the problem, determine what type of division is this. Is it dealing or is it measurement? So I hope you've enjoyed this. Thank you for your attention.